So certainly one of the efforts within TAMEST is to be relevant and useful to challenging technological issues in Texas. And this is a report focused on a water summit that was put together in May of 2012. There is a report available, and that report will be available as you leave the room if you don't yet have a copy. But our effort in this water summit was, of course, to both evaluate and consider both challenges and opportunities associated with the water problems that we've faced over the past year. Let's see. Trying to see how my controls here. Which one do I use?
Square one.
This one? There we go. All right. So we all know why we started this water summit. And it has to do with the fact that if we look back in 2010 in a satellite photo of Texas, this would be a relatively normal year or a wet year. But in 2011, what did we see? We saw really a decimated environment because of a very hot summer and a very dry summer. That drought in 2011 is the worst single-year drought in Texas history, and it exposed a lot of issues that we had, is that we didn't necessarily understand the current conditions as they were developing. An example for those of you that live in and around Austin, and we're certainly concerned about the fact that enough water was sent downstream during that very hot year for 2 rice crops. And as a result, there's been no rice crop in 2012, and there may not be any in 2013 because of the water that was depleted from the reservoirs at that time. If we'd have had situational awareness, perhaps we would have limited the efforts to 1 rice crop, and we would have been able to continue to have at least 1 rice crop over the these last 2 years. But we didn't really have that. We'd like to be able to see ahead 6 to 18 months, but that isn't available to us right now. And even more importantly, there's an old joke in this business that never let a good drought go to waste. And the reason is because a drought is when people focus on planning for the future, recognize there are issues, and certainly that drought brought to the fore concerns about long-term planning for drought. Recognizing that we have an expectation of an 80% growth in our state's population over the course of the next 50 years, and that really is gives pause to where that water might come from if we have similar sorts of drought. We also saw that it's clear that as a result of that need for planning that we can't simply wait for it to rain. So it was within that context that this water summit was put together. Certainly an important challenge for the state of Texas, and I'd like to acknowledge the group of primarily academics that serve as center directors of water research centers across Texas that serve to help organize this and that are identified in the program. But we put together this program with TAMEST's help and with this organizing committee to try to evaluate both what is our long-term prognosis for the availability of water, but then also to identify what are our opportunities given current demand, given expectations for demand, how can we conserve that water, what are our opportunities for conservation, and then ultimately there is a gap between what we might be able to conserve, what we expect to have available, and what we think we're going to need, and how do we fill that gap with new supply. So that was the purpose of the summit. We had it kicked off with a couple of keynote speakers that identified some of the key issues and our current level of understanding, and that with a variety of other speakers to address each of those areas, both the challenges of availability, conservation, and new supply. And then a little bit before I talk about what we actually did within the summit and what we learned from it and what our current situation is relative to the summit, just a little bit of an idea of who was there. It was a standing room only event. We planned for something on the order of 200, and then we filled the room as best we could, ultimately ending up with 234. We have distributed this report that I had just mentioned to some 700 plus recipients, including all the members of the legislature, and of course to many of you that are already in the audience, and we'll add to that number hopefully as you leave the room. We also had a number of virtual attendees. It's organized on the TAMEST website in a manner so that you can go through the presentations and actually be almost there and actually view the entire summit, even if you were not able to attend. And this isn't just the people that happen to click on the website here and there, but actually page through the detailed presentations. Well, what did we talk about during the summit? Again, water availability now and in the future, the demand that we expect, and what's the potential for conservation in each of the areas that are identified there, some of the critical needs that we have in some of each of these areas. And then to fill the remaining gap, what is the potential for new supply? And largely our discussions were focused on water reuse and desalination. If we look at the availability, and I'd like to go through each of those areas and talk about where we were relative to the summit, and as well with some of our current information, what we have learned in the summit. How does that inform the way we see ourselves right now? And on this slide, in the bottom figure, is the colored areas represent the percentage of the state that is in some state of drought. And as you might expect, red means an exceptional drought, and to yellow is just perhaps a mild drought. But I think that figure over the last 10 years really makes it clear, and certainly one of the lessons of the Water Summit was that we really do have a climate that is perennial drought, separated by, unfortunately, very occasional floods. And there's perhaps only 3 periods there when some portion of the state is not in drought. And the vast majority of the time, and I would suggest that even on average, more than half of the state is in some state of drought over the past, at least the last decade. Also, however, it shows how exceptional the 2011 drought was, which is that in the lower right-hand side of that figure. But it also, perhaps hidden behind that legend, it turns out that some 97% of the state right now is in drought. We got a little bit of rain last year. It lessened the severity, but we are still in a drought over, again, 97% of the state. As of January 2013, the figure of Texas in the upper right shows the state of that drought. And those white areas are the only areas that are not in drought. And again, the red and dark red represent very strong and exceptional drought periods, or areas. Perhaps even more, something that gives even more pause, at least to me, is when if we look back, something that John Nielsen Gammon presented during the Water Summit, there's really quite a good relationship between temperature and rainfall in Texas, summer temperatures and summer rainfall. Over the past 100 years, a good description of rainfall has been, again, well correlated with temperature. Unfortunately, we expect temperature to rise, and if they remain correlated, it may cause and effect isn't clear here, but if they remain correlated as they have in the past, and if we expect a 4-degree temperature rise over the next 50 years, it means that our average now sits there at perhaps half of our rainfall that we currently have, and much closer to 2011 on average than we would like. So we can see that we have some real challenges relative to availability of water into the future. We spent most of the summit trying to decide how we could respond to that. First of all, with respect to conservation, when we look at the current demand, 85% of our demand is in irrigation water for agriculture and municipal residential uses. Clearly, of that 85%, if there's going to be any significant conservation, it has to come in those 2 areas. I would suggest that the rest of the areas, which includes all oil and gas exploration, what we use for manufacturing, really all other sectors, if we drop them to 0, we still wouldn't necessarily satisfy our needs during severe drought. So it is going to be, conservation really needs to come significantly from these 2 areas. I would have to say that we didn't talk an awful lot about agricultural irrigation Because it is 6% of the water, I think it deserves its own summit. Perhaps an additional meeting where we can focus on some of the opportunities there. But we know that there isn't a lot of opportunities. There is some efficient irrigation systems, drip irrigation, field leveling. It's been used across the state to try to help hybrid crops that use less water. There's a lot of activity in this area. And clearly at 56% of the water, it becomes very important. I also find it interesting that we are in a push to grow food locally and use food locally, but in Texas at least, we probably also need to couple that with recognizing that we need to look at what the water footprint is, and not just the carbon footprint of using our food locally, but the water footprint of growing particular crops in Texas. Municipal residential, 27% of demand. Again, another place where there is at least opportunity and a need for significant conservation. Let's examine what the potential is there. And that's where we did spend a fair amount of time with that. And there we go. We had a presentation by Robert Puente as part of the summit on San Antonio. And they really have been leading the way for Texas and for really much of the rest of the nation. And the key ingredient there is 67% more customers in the San Antonio water system between 1984 and 2009, but no additional water. And in fact, Robert Puente made quite a compelling case for a business model where he reduces sales, that his effort is to try to reduce the amount of water that they sell. And it's kind of an unusual business model to reduce sales, but in fact, it made quite a compelling case for that. Because of this increase in population with no increase in water, enabled the city of San Antonio to avoid additional Edwards aquifer withdrawals and a savings associated with those withdrawals. And if they'd used enough water that they had to turn instead to groundwater desalination, the fact that they were able to save the costs of building such a plant and desalinating that water, estimated $1.9 billion. And if they had tried to build new surface water facilities, the expected cost was $3.3 billion. And this was all on the basis of an investment of $84 million to try to limit growth of, or increased demand of water as the population increased. So $84 million worth of conservation programs of all sorts to try to help people, everything from low flow faucets to low water use toilets, a variety of means, spent $84 million to save $3.3 billion. We may very well face a very similar situation with Texas because we expect an 80% growth in population over the course of the next 50 years, and it's going to be a real challenge to keep anywhere near zero growth in water demand for that. If we're not using water on the front end, it also means we're not using water on the back end, and again, San Antonio showed the savings if using conventional or treatment, depending upon what degree of treatment would be required for that additional water that they might require for that 67% growth in population, by not having to build the wastewater treatment plants, not having to go to alternative treatment systems, again, saved $1.1 billion. So it is quite an interesting business model, is that we're going to reduce the size of the business and make more money. But that effectively what Robert Puente was able to make a compelling vision of. If we look in general at conservation, certainly there's some opportunity. But when we're thinking of an 80% growth in population over the next 50 years, it's hard to imagine that we can even break even. That is, that we would expect that the residential and municipal needs for water will probably increase somewhat, although there will be a great deal of pressure to try to maintain conservation through many of the things that San Antonio, for example, has led the way with. Certainly agricultural irrigation at 56% of our current water demand is a prime source for trying to conserve. Some of the challenges there is that this sector doesn't generate a great deal of income that would allow some of the more expensive solutions, and they're probably going to need an awful lot of help in order to conserve water. Our current water pricing structure, namely that we don't really value water, at least monetarily, means that there's little incentive for that right now. And we also have a water right structure that does interfere with connecting where water needs are to supply. That's also illustrated in this slide, where when we look at the demand for water currently in the state, again, 50% irrigated agriculture, very small amount for livestock of the order of 2%, 9% for mining, modest amount for manufacturing, and again, remember the 27% for residential. But if we look at the economic value to the state in terms of the Texas domestic product, that 56% of irrigated agriculture translates to 0.6% of the economy of Texas. And that is a stark contrast that I think is a real driver for ultimately developing a functioning water market that could connect where the demand is, where the demand needs to be with the economic value in the state. And there will certainly be a push in that direction over time. Well, we're not going to get all the way there with conservation, and again, it's quite unlikely that we're going to get all the way there by conservation, especially in light of an 80% growth of our population over the next 50 years. So what are the options in new water? And we spent the afternoon of our water summit looking at some of those opportunities. Aquifer storage and recovery, it's certainly perhaps an obvious solution because a lot of, especially in West Texas, where reservoirs are so low, some of the associated with that is, of course, evaporation from those reservoirs. A way around that is to use aquifer storage, subsurface storage, rather than surface storage. We actually have some impediments to that. Once we put store water in groundwater, who owns that groundwater? How do we get it back out? There's some perhaps relatively small impediments, but they have slowed at least the use of aquifer storage and recovery, and it's certainly more expensive and more difficult than surface storage, even if it is potentially more efficient. Water reuse is undoubtedly in the horizon, and we tend to think of it in two different ways, direct and indirect potable water reuse. The direct potable water reuse faces an uncertain future. There's not strong public acceptance of that. You know, the jokes of toilet to tap and things like that make direct water reuse difficult, but it also has technological challenges, namely dealing with things such as pharmaceuticals, which are not easily treated in our wastewater treatment systems. How do we make sure that our reuse of that water manages things like that effectively? Indirect is much more viable. This is where you return it to the environment. For example, the wastewater goes into a stream and then is recycled back to a system. And we certainly do that now if we have multiple cities on the same river that are taking drinking water that are at least composed partially of effluent from the upstream municipality. And then finally, desalination. Certainly there's an opportunity in seawater to desalinate. It requires an awful lot of energy. Even if we make it as efficient as possible, there is a theoretical limit to how much energy is required to desalinate seawater, and it's quite high. It will be more expensive than our current sources of water. We also have an opportunity in inland brackish waters, and, excuse me. Go back to this for a moment. Inland brackish waters, which I'm going to touch on a bit more, it's certainly quite an opportunity. It has a little bit less cost than some of the seawater because it's lower in salinity often. But there are some issues there in that how do we effectively regulate that water? We don't have a system to deal with that, although it's improving. In fact, just a couple of days ago, the TCEQ announced some procedures to streamline permitting to use inland brackish waters. But it is a finite resource, and so we have immediate sustainability concerns, and we don't know as much about that resource as others. And we also don't have a place to dispose of the concentrate, which is a natural effluent from desalination. It becomes more difficult when we can't return it to the sea. There are certainly areas out there that have experienced some of these same problems, and it's a lot easier for a small city-state like Singapore to manage some of these issues, but it does show a path forward. Only about 20% of their future water expected needs in Singapore are available in terms of the local catchment water. Right now, they get an awful lot of water by importing from Malaysia, but that's not expected to be able to continue for into the future indefinitely. There's not that good a there's never been much of a good relationship between Singapore and Malaysia, but that imported water is likely to no longer be available. And as a result, Singapore has turned to new water, which is effectively that direct reuse water, and they expect that to be half of the total water very soon. And in desalination of seawater to provide the other 30% that might be needed. So this is at least a path forward for us. I don't think we would ever get to quite these numbers, nor can we easily implement this as Singapore is, but again, it is helping move this forward. Now, I mentioned the saline groundwaters. On the right, I have the areas of oil and natural gas production in the United States. On the left is a map of saline groundwaters in the U.S. And you can see that we actually have a saline groundwater resource that exceeds even our oil and gas resource. We have quite a saline groundwater resource. That saline groundwater, many of it is brackish rather than as salty as seawater. The less salt that's in it means that desalination uses less energy and is less costly. And so it is quite an opportunity, and it's interesting as well that much of the arid sections of the U.S., the Southwest, including Texas, are actually quite rich relative to this saline groundwaters. So it provides an opportunity. Right now in the Texas Water Management Plan, only a very small fraction of the new water that is needed is expected to come from this. I would not be at all surprised to see that grow as we improve our ability to tap into that efficiently and economically. But in general, our new resources are going to be the result of either increased reuse, which is that blue line to the left, and this is our past record and what we expect to happen. We expect to see continued reuse. This is nationally, not just in Texas, but that trend is also going to be repeated in Texas, and then an increasing amount of desalination. And it should be emphasized, desalination is not an exotic technology. The volume of water that is generated worldwide by desalination actually exceeds fairly significantly the amount of oil and gas that is produced internationally. So there is an awful lot of desalination, but there's still an awful lot of work to be done to make it efficient and economic. And that's illustrated on the right, just showing the energy cost associated with brackish, which is the third bar, compared to seawater, which is the fourth bar. The smaller we can make that, or the closer to the origin that we can make that, the more efficient and more economic the technologies. So where did the summit leave us? I think quite clearly, as with solving our energy problems, there is no magic bullet, there is no single solution. We need both tools to better assess and predict what our future water supply might be in the short term as well as long term, and conservation, reuse, and advanced treatment technologies for new water are a necessity for us to meet our economic development plans and population growth. And so let me close with a slide where we think TAMEST can help in this. And we've been working over the past, well, since the summit really, to try to develop these. First of all, we think that TAMEST can help organize and encourage both academic, and I really should have industrial research there as well, to help improve the tools that we have to understand the drought conditions, water conditions, but also to help develop our technologies for wastewater and drinking water, et cetera. The treatment technologies necessary to develop new water can help play a role to, we just had a meeting at breakfast this morning of academics working in water that TAMEST helped organize. That's an example of a role where we can coordinate some of the activities to help address those issues. We also had a meeting at lunch yesterday with the Industrial and Community Affiliates Committee of TAMEST, chaired by Sarah Ortwine, where we were challenging the Industrial and Community Affiliates Committee to become engaged in this water issue, that it is too important, that the economic development of Texas will be limited unless we can minimize the cost and the problems associated with our limitations in our water future. And so I think that they're seem to be taking that on board, and we certainly hope that they can become engaged and help get industry engaged. In many cases, I think we see residential and municipal and the agricultural interest seem to be the voices we hear the most. The industrial voices need to be heard a lot more to recognize that they have a place at the table in trying to ensure that water is available for the economic future of the state. And then the third is to try to seek novel solutions. One of the things that came out of the summit was a recognition that the water management plan was, in the state of Texas, built from the bottom up. Individual water management districts that effectively the state water management plan is a stapling together of those plans from the individual districts. And I would suggest that is a recipe for ensuring that the plans are somewhat more of the same. And that we need a fresh look that looks more holistically across the state that can evaluate things such as interbasin transfers. How much should that be a part of the issue? I think that one way of perhaps moving in that direction is to have TAMEST develop a National Research Council-like role for the state of Texas. That is to convene a committee of experts that don't have vested financial interests on this particular issue and try to seek those outside-the-box holistic solutions. And we have encouraged that TAMEST pursue this. With that, let me stop and respond to any questions you might have, and thank you for your attention. Yes.
What are the prospects for a complete overhaul of water rights laws? I read yesterday in the Wall Street Journal that Texas is in lawsuits with New Mexico and Oklahoma about water rights. So it obviously has to be done at a federal level.
Well, there's two sets of issues. Certainly between states is one set of issues, and Texas at least believes that there is a legal standing to open up some of the limitations they have from those states. Perhaps our biggest issue is within the state and the seniority-based system that we have historically had, and most of the West has, in terms of allocating water rights. And there's a lot of pressure on that, as you might expect. Part of the answer to that is probably going to be in terms of a functioning water market. That is, someone who has senior rights recognizes that it might be more favorable to sell those rights than to actually grow some low-value crop with them. You also will see some pressure, and there is currently pressure to ensure that municipalities have the water that they need. For example, there's it is in a lawsuit right now. It's not clear how it will develop, but TCQ, I believe, made a decision to override senior water right holders to provide some needed water to municipalities. The senior right holders have since sued, but there's going to be continued friction, and there's undoubtedly going to be a slow shifting away, either by buying those rights or by changing the legal system towards other uses of that water than the historical users. I don't think there's any question that movement will be that direction. Yes?
With the expanding horizontal drilling and fracking, what is the prognostication about possible contamination of the aquifers?
Well, I think that there certainly is a lot of activity trying to evaluate to what extent there may be contamination of aquifers associated with that oil and gas drilling. I personally believe that it's not significantly different or not really different at all from conventional oil and gas drilling, and there are certainly potential environmental issues if, for example, at the surface material is not handled properly or there's spills or leaks. But I don't see that there's a significant difference between hydraulic fracturing and conventional oil and gas exploration activity. There is concern, probably the biggest concern right now relative to this particular issue is the competition for water for hydraulic fracturing versus other uses, agricultural or municipal. In general, the amount of water that's used in hydraulic fracturing is a very small fraction of the total volume of water that's in use right now in any region. But there are local dislocations, and those are also perhaps where some of the work with the water market, a functioning water market, will perhaps first begin to rear its head.
Two more quick questions.
Could you comment on the use of water for power production? For example, it takes about 2/3 of a gallon of water to produce 1 kilowatt-hour of electricity.
Well, there's two aspects of water for power production. One is withdrawals, and actually in terms of withdrawals of water from surface water, power is the #1 user of water in Texas. However, almost all of that water is returned to the surface water, and in terms of consumption, the power industry is a very small net consumer compared to the other ones that I mentioned. I think the biggest challenge with power is that because of drought, because of low surface water flows, some 77% of the water for power generation comes from surface water right now. And as that water levels decrease, as the flows in the rivers and streams decrease, that's put many power plants at risk of not being able to withdraw the water to actually operate. And that has been a potentially significant problem that we have come close to the edge, but we have not quite gotten there. But we were very close during the drought, and early in 2012 we were close to having to shut down power plants as a result of not having water to be able to withdraw into the cooling systems. There are efforts as well to try to change those cooling systems, but as you might expect, they're not energy efficient, and they're expensive to move to, say, dry cooling.
How significant is reservoir evaporation, and at the meeting, was there any consideration for schemes for reducing reservoir evaporation?
Well, certainly it changes quite a bit across the state, and the net evaporation becomes more and more significant, in fact becomes significant as we move west of the I-35 corridor. East of the I-35 corridor, I don't believe it's a significant factor at all. But for the West Texas reservoirs, it's certainly an issue, and I think that's one of the drivers behind aquifer storage and recovery to try to overcome that problem.
I was thinking about crazy schemes like putting plastic film over the surface of the reservoir.
There have been some evaluations of that. I haven't seen any that suggest that it's feasible to have a significant impact. Perhaps the more efficient way to do it would be to build, if we could solve the interbasin transfer problem, would be to have reservoirs in East Texas supplying water to Central and Western Texas. But we still have the interbasin transfer problem to solve in that regard.
Thank you very much. That was great.